Hi, Assalamualaikum. My name is Nur Afifah binti Mohamad Senawi. So I'm going to present lab 6, OHM'S law using multisim simulation. Okay, first of all, I need to set up a circuit that consists resistor, emitter, power supply and switch. Okay, this is my circuit in multisim. So I already set up the voltage for 3 volt and the resistor for 200 ohm and put the emitter there to check the current. Okay, after that we need to run the simulation and then look at the grapher. So this is the value of current that we need to find is 14.926 milliampere. Okay, for table 1, we need to find the current intensity measured. So based on the circuit in multisim, we can find that the current is 14.960 and put it in the table. So we repeat the step for 6 volt, 9 volt and 12 volt of power supply. Okay, next we move to the current intensity theoretical. So to find the theoretical value, we need to use the formula V equal to IR. Since voltage equal to IR, so the current equal to voltage over resistance and the value for voltage is 3 volt. Value for the resistance is 200 ohm. So we can find that the theoretical current for this circuit is 15 milliampere. Okay, I also repeat the same step for the theoretical value. So I get for 3 volt is 15 milliampere, 6 volt for 30 milliampere, 9 volt 45 milliampere and 12 volt 60 milliampere. Okay, the next step is we need to run the simulation and look at the grapher. So I can find that my current for this circuit is 73.166 milliampere and put it in my table. For table 2, I just changed the resistance value because the voltage value need to be same for all the circuit 5 volt. So this is my value for current intensity. For the theoretical value of current in table 2, I also use the same formula V equal to IR and I got the current for theoretical value is 73.529 milliampere. Okay, so here our value for table 1 and table 2.
Okay, my name is Hanif bin Jamaluddin. So I'm going to explain for questions and discussions. For number 1, from your data table, examine what happened to the current when the voltage was double, triple, quadruple, and etc. So when it's double and tripled and etc., the value of the current will increase at the same time. So if the voltage increases, the current will also increase. So moving on to number 2, based on 1, what type of relationship do you believe exists between voltage and current? So the relationship between voltage and current is if the voltage increases, the current in the particular circuit will also increase. Next, from your data table, examine what happened to the current when the resistance doubled tenfold. So what happened to the current is the current will decrease drastically. So it will drop from like a high number to a very low number. So when there is current and resistance in a circuit, the current flowing in the circuit is directly proportional to the applied voltage and inversely proportional to the resistance of the circuit. And for number 5, which is the graph, so by using Excel, plot a graph of voltage V versus current intensity MA for simulation and theoretical result in table 1. So the first graph is for current intensity for simulation, which was simulated in MULTISIM. So this is a voltage versus current graph. So the voltage starts from 0 to 4, 6, 8, 10, 12 and 14, and for the current intensity starts from 0, 10, 20 and 270. So the numbers that are placed on these markers are the current intensity in the circuit. First, it starts at 14.96 to 29.92, then to 44.879, and finally the max value is 59.839. Okay, and then for the second graph is voltage versus current intensity, and for theoretical. So for theoretical, a formula, the Ohm's law must be used to get these values. So for current intensity it's 0, 10, 20, 270, and for voltage is from 0 to 4, 6 until 14. So 15, 30, 45 and 60 are the values for the current intensity which is calculated using Ohm's law. Okay, so for number 6, this is the graph for current versus resistance. So for the first graph is for the simulated one. So we can see the values here. 73.332 is the highest value of the current which is measured, and then it drastically decreases to 4.9866 to 1.061 and finally to 0.4986. Okay, for the second graph is for current intensity for theoretical. The highest value is 73.529, and then it goes to 50, 5, 0.106 and finally 0.5. So the relationship here is as the resistance increase, the value of the current will decrease at the same time. Okay, and for the last part, the conclusion, Ohm's law states that the current through a conductor between 2 points is directly proportional to the voltage across the 2 points. Introducing the constant of proportionality, the resistance 1 arrives at the usual mathematical equation that describes this relationship, where I is the current through the conductor in units of amperes, V is the voltage measured across the conductor in units of volts, and R is the resistance of the conductor in units of ohms.